Welcome to Chapter 5. The first topic is continuous random variables. We consider a continuous random variable capital X, which can take any real value on the real line. By definition, X is a continuous random variable if there exists a non-negative function. So notice that you have to have a non-negative function. We use small letter f for this non-negative function defined for any X on the real line, such that for any set B of real numbers, you will have the probability that the random variable falls into this set to be the integral of this non-negative function where X is in that set. Okay? So once we define continuous random variable in this way, we have a special name for this small fx. It is the probability density function. In short, PDF of the random variable X. Earlier in previous chapter, chapter 4, we talked about the discrete random variable and we talked about probability mass function and PMF. Here we talk about probability density function because we work with a continuous random variable. Some examples here: rain for a month or a year can be a continuous random variable, lifetime of your first car, amount of beer consumed on a game day. So pretty much it is continuous. You can think of that you can measure, but you cannot count. So very important here, PDF and the CDF and their relationships. So for a PDF to be valid, the probability density function, in addition to being non-negative, we also need to make sure that the integral of fx dx from negative infinity to positive infinity to be 1. Okay, so that is making sure that we are having a valid probability density function. And once we define it this way, if you think about the cumulative density function, remember, it is the density function up to that point, cumulative. Then we use capital F to denote that, if you remember, and then we write small a in here. By definition, this is CDF, regardless of whether you have a continuous random variable or negative or discrete random variable. However, when you're working with continuous random variable, by definition, you're integrating the CDF of a continuous random variable. You're integrating fx dx from negative infinity to a. Okay, so you're integrating your density PDF function up to that point. And that's how we define the CDF for a continuous random variable. And very interestingly, once we come to this point, you will notice that, well, if I'm looking at the random variable, continuous random variable, to take any particular value, the probability is actually 0. Because by definition, you're integrating fx dx from this point to that point. And when you work out the math, it's going to be 0. Another way to look at it will be, well, if I'm looking at the probability of x smaller than some value a, it will be my CDF minus that point. And then you can also see that, well, it actually becomes FA as well. And once you have these two equal to each other, this is telling you that probability of x equals to some particular value a will be 0. So that's something very interesting and important to grasp for continuous random variable. And lastly, if we're looking at probability on the interval from a to b, it will just be the difference between the CDF evaluated at b minus the CDF evaluated at a. And again, because at a particular value a or b, the probability of x taking that value is 0, so you can have including a or b or excluding a or b, they're all going to be equal to each other. So just graphically, this shaded region is what we mean by the probability of this random variable to fall into between a and b. Okay, so this curve is the PDF that we've been talking about. And what you're doing is you're integrating the area under the curve between two values. And this will be the probability that the random variable falls into this region. And lastly, between PDF and CDF for a continuous random variable, if you know the PDF, then you can come up with the CDF by doing integration from negative infinity to that value that we're looking at. And if you know the CDF, then you will just simply take the derivative. Okay, take the derivative of the CDF with respect to the random variable x. So now for you to practice, suppose that x is a continuous random variable having this PDF. Can you compute the value of c? The hint here is that, remember, in order to have a valid PDF, you will have to have the integral from negative to infinity fx dx equals to 1. Okay, so think about how you can use the information here to solve the value of c.